नमस्ते बेटियों, खुश रहिए. I JVN Muskan Kumari from the Department of Science and Technology, and I'm working here as an assistant professor in JVWU Women's University and Faculty of Education and Mythology. So today in today's session, I will discuss the basic data structures in Java, isn't it? And this is not the basic that data structure in Java, but this is basically implementation of data structures and in the coding forms of the Java in basically on the data which we have in the form of the structured, isn't it? We have to convert that unstructured format of data into the structured format of some data. So I have implement the data structures on that one using the Java languages. Clear? So I'm just going to share the some files to make it an easy way to understanding all of you. So here, yes, this is the files which we will discuss regarding the data structures in Java, and this is basically you can also call that like the clustering, isn't it? The data structures in the sense the clustering of data structure in Java. So now it's well known that we can classify the any algorithm in the two based on the amount of supervision they can use during the training process. There are two types of the learning algorithm. First will be the supervised and second will be the unsupervised. In supervised learning algorithm, what will happen? The training data should include the actual solution for each point. In which training data, what happened? Training data includes the actual solution at each point. For example, if we are about the train and our spam filtering algorithm, we feed both the sample emails and their labels also, and spam or not spam to the algorithm. Mathematically speaking, we are going to infer the effects from the training set, including both x and s, x's and y's. Isn't it? We can say like this in the mathematical form. And if we talk about the unsupervised learning, then there are no labels in training data, and then the algorithm is unsupervised one. For example, we have plenty of data. Suppose we have plenty of data about the musicians, and we are going to discover a group of similar musicians in that data. So there is very difficulties in this one, and there are no any levels through which we can categorize this data. Okay, so now no clue like the no proper uh, no proper have any on which we can categorize that things, isn't it? So clustering that. mm, what is the clustering? That clustering is basically considered into the unsupervised algorithm to discover groups of similar things, ideas, or people. Unlike supervised algorithm, we are not training clustering algorithm with an example known as the levels, and instead clustering to find a structure within the training set where the no points of data is in that level. So here is the key means clustering. Key means clustering. Key mean is a clustering algorithm. This is a algorithm of clustering with one fundamental property like what? The number of clusters is defined in advance. How many clusters you will use, the number of clusters is defined in advance. In addition, key means there are other types of clustering algorithm like hierarchical clustering, affinity propagations, and also the spectral clustering also. Okay, how key means clustering algorithm work? Suppose our goal is to find a new similar groups in the data set. Isn't it? This is a data set, and here we have to find the new similar group of the data set likes. And key mean begins with key randomly placed centroids. Key mean starts the searching the dataset with the placed in the centroid. Centroid, as their name suggests, that they are center points of the cluster. Okay, for example, we are adding four random centroids four random centroids in this one. K means K randomly placed centroid, and this is one. Then we assign each existing data point to its the nearest centroid, assigning the each data to its nearest centroid point. Okay. Now, what will happen? Then we assign each existing data point to the nearest centroid, and after the assignment, we move centroid to the average location of points assigned to it. Remainder centroids are supposed to the center points of the clusters also, and the current iterations conclude each time we are done relocating the centroids. We repeat these iterations until the assignment will run multiple consecutives, and also at last the algorithm terminates for those four clusters and found expected. Now that we can know how key-mean works, let's implement it in the Java form. So future representations within the modeling different training data set, we need a data structures to represent model attributes and their corresponding values. For example, musician can have generate attributes, generally attributes with a value like raw. We usually use the term features to refer to combination of an attribute and its value. So to prepare the data set for the particular learning algorithm, we usually use a common set of numerical attributes that can be used to compare different items also. And for example, if we our users tag each artist with a genre, then at the end of the day we can count how many times each artist is tagged with a specific genre. The features of the vector artists like the Linkin Park is rock 790, MU means 700, alternatives 520, pop 3. So we could find a way to represent the attributes as numerical value. Then we can simply compare two different items, example artist, by comparing their corresponding vector entities. Now, this is the implementation in the form of the Java like what? Public class record, private final string description, and private final map string double features. Here we will use the constructor getter and two strings equal and hash code also. Finding the similar items. Suppose if we have to find the similar items from the clusters, then what we will use? In each iterations of key means, we need a way to find out the nearest centroid to each items and of the data set. One of the simplest way to calculate the discrete distance between two features vectors is to use the Euclidean distance. The Euclidean distance between two vectors like P1 and Q1 and P2 and Q2 is equal. Let's implement this function in the Java. This is a type of the abstractions like you will use here the class of public interface distance double calculate here map string double and map string double f2. There is two. In addition to Euclidean distance, there are other approaches to compute the distance similarity between different items like the Pearson correlation coefficient. The abstraction make it easy to switch between distance, different distance matrix. Let us see implementation for Euclidean distance like what? Public class Euclidean distance implements the distance, isn't it override? Here you are using public double calculate map string double f1 and map string double f2. Double sum equals to 0 for a string key f1 dot key set and double v1 equals to f1 dot key and double v2 equals to f2 dot gate key. Now if v1 not equals to null and v2 not equals to null, sum equals to math power v1, v2 and 2. v1 minus v2 to power 2. Okay. Return math dot squared sum It means whatever the calculation of this one power is stored into the sum. So returning the value of this sum, that sum into the square form. Isn't it? First we calculate the sum of square difference between corresponding integers. Then by applying the square function, we compute the actual Euclidean distance. And now if we talk about the centroid application, so what happened? Centroid are in the same space as normal features, so we can present them similar to the features like public class centroid, and here you can see that the same public string double coordinators, constructor, getter, and two strings equals and has to. Now, if we have a few necessary abstractions into the places, then time is to write for the key means implementation. Here is the loop of the methods like you are making a class that means k means private static final random equals to nil random public static maps centroid list record fit and records integer k distance int max listener iterations, and that is the omitted. And this is the breakdown of this method is like what the data set is the set of features vectors since each features vector is record, each feature vector is a record, then the data type is list record. The key parameter also determines the number of the clusters which should provide in the advance also. Distance encapsulation, the way we are going to calculate the difference between two features. Key means terminate when assignment stops changing for a few consecutive iterations. In addition to that termination condition, we can place a upper bound for the number of iterations. So the max iterations argument determines the upper bound. And the when key means terminates, each centroid should have the few assigned features. Hence, we are using the map centroids also and records list also, and the return type basically each map may includes the to the cluster. So this is all about your the today's session, isn't it? So please read this session from the different standard books and also follow the multiple sites and also follow some ancient literatures. Okay, so if you talk about that any standard books, then I will suggest to you that please read the books. And there is a book for the Hadoop for Dummies type, isn't it? And there is also one book's name that Hadoop, the Definitive Guide, Storage and Analysis and the Internet Scales. And for the programming section, you use the programming high data warehousing and queries language for Hadoop, isn't it? So please read this books also and use multiple sites also and read that all the things. If you want to read some important techniques with their implementation, then you can also use the Hadoop in practice. That includes the 104 techniques, isn't it? So there are so many books are available and the online websites are available through which you can get the more and more contents regarding this topic. And if you have any problems in this session, then please do comments in the comment section box through which we can see and discuss that query with you in the next session. Okay, thank you. And many more questions will be arises from this. What do you mean by supervised learning, unsupervised learning? How k-mean clustering algorithm are working? Please show this type this in the implement with the implementation of Java. Okay, so please be prepared for this session and also for the previous all session. Okay.